Alright, welcome back everybody. In this video we're going to discuss how we calculate simple probability. And what simple probability is it's just the probability of a single event occurring. And we're going to use this formula right here to find the simple probability. To find the probability of a single event occurring, the probability of that event, and you see right here, this is the notation that means probability of something. Probability of the event is equal to the number of ways that the event can occur, whatever the event is, divided by the number of possible outcomes in the situation. And our probability will always be a value from 0 to 1 when we're talking about it as a decimal. It's going to be between 0 and 1. If we're talking about it as a fraction, again, it's going to be some fraction between 0 and 1. When we talk about it as a percent, it's going to be between 0% and 100%. Something that has a 0% chance of happening will never happen. Something that has a 100% chance of happening will always happen. And most of our probabilities fall somewhere in between those two. It's rare that anything is absolutely not going to happen or absolutely definitely going to happen. All right. So let's go on to look at some examples of calculating simple probability. Jose has a bag filled with packs of Pop-Tarts. There's 5 packs of blueberry, 3 packs of frosted strawberry, 2 packs of peanut butter and jelly, and 4 packs of chocolate fudge. If he picks 1 pack of Pop-Tarts out of the bag, what is the probability that it is A, blueberry? Okay. So when he reaches in and picks a pack of Pop-Tarts out of his bag here, the number of ways that he can pick out a blueberry Pop-Tart, pack of Pop-Tarts, depends on how many packs of blueberry are in the bag. There are 5 packs of blueberry in the bag, so that is the successful outcome here, if he picks a blueberry out. And then we need to divide that by the total number of possible outcomes. And the total number of possible outcomes is dependent on how many total packs of Pop-Tarts there are in the bag. And so we add up all the total packs of Pop-Tarts in the bag, and it looks like he's got 14. So the probability that he picks out a blueberry pack is 5 in 14. Now, I could also write this as a decimal or as a percent. So I'm going to go ahead. 5 over 14 gives me that as a decimal. It's 0.357. Or we could write it as a percent, and to get the percent, we just shift the decimal point over 2 places to the right from our decimal value. And so the probability of a blueberry is 35.7%. We'll do the same thing to answer the rest of these questions. 2 packs of peanut butter and jelly. So the probability of picking a peanut butter and jelly is 2 out of 14, which we can reduce to 1/7. And then we could also represent it as a decimal if we wanted to. 0.143, or as a percent, 14.3%. So any of these 3 answers, the reduced fraction, decimal, or the percentage, would be good. Chocolate fudge. Number of successful ways of pulling a chocolate fudge is based off how many packs of chocolate fudge there are. So we've got 4 out of 14, which we can reduce to 2 over 7. If we do that as a decimal, we get 0.286, or 28.6%. And then frosted strawberry, there are 3 frosted strawberries, so the probability of getting a frosted strawberry is 3 out of 14, which again I can represent as a decimal or a percent if I want to, 21.12214. Now, of course, when you're finding probabilities, you don't need all of these, you just need one of these representations. And if you're told to represent it a specific way, like percent, or if you're told leave it as a fraction, go ahead and do that. But other than that, you can choose any of these three. Some of them feel more appropriate in different contexts. All right. Next example. Suppose you roll a standard 6-sided die one time. What is the probability that you will roll the following? Now, a standard 6-sided die, if you don't all remember, is a cube with the numbers from 1 to 6 on it. So those are all the possible outcomes he could roll. They're all equally likely, 1, 2, 3, 4, 5, and 6. So there are 6 possible outcomes. So all of our calculations here will be out of 6. Chances of him rolling a 3. Well, there's only one side that has a 3 on it, so the probability of that is 1 over 6, which if we write it as a decimal, it's going to be 0.167, or if we write it as a percent, 16.7%. All right, next, an odd number. There are still 6 possible outcomes. The odd numbers, there are 3 of them, 1, 3, and 5. So the probability of that is going to be 3 over 6, which I'll reduce to 1/2. Or if we want to write it as a decimal, 0.5, or as a percent, 50%. A number less than 5. There are still 6 possible outcomes. How many numbers are there that are less than 5? 1 is less than 5, 2, 3, 4. 5 isn't less than 5, so we don't count that, or 6. So there are 4 successful outcomes where we will get a number less than 5. I'm going to go ahead and reduce that. And if we wanted to, we could find it as a decimal or as a percent. Either one of those would be fine as well. And the last one here, the probability of rolling a 7, well, there aren't any sides of the die that have a 7 on them, so the probability of rolling one of those, there's no successful outcomes when I roll that die, and so the probability is 0, or 0%. All right. One more example. A jar contains 10 red marbles, 8 green marbles, 5 blue marbles, and 6 white marbles. If you reach into the jar without looking and pull out one marble, find, first, probability that it's red. Well, I need to know how many possible outcomes there are, and in order to get that, I'm going to take all of the numbers of marbles and add them together. And there are a total of 29, 10 plus 8 plus 5 plus 6. So that's going to be my denominator for my fraction. And we want the probability of red. So a success is pulling a red marble. There are 10 ways that we can do that. So our probability is 10 out of 29. Or if you want to find it as a decimal, you're welcome to do that. But 10 over 29 is certainly an acceptable answer here. We get 0.345. Or 34.5%. So any of those 3 would be a good answer for that one. Next, the probability that it is not green. Okay, so what is a success for not green? Any of the other 3 colors. So 10, 5, 6. If I add all those up, there are 21 marbles that are not green. So the probability of getting something that's not green is 21 over 29. Or if I want to calculate out the decimal, 0.724 or 72.4%. Okay, any of those would be a good answer. Next, the probability that it's purple. Again, there are 29 possible outcomes, and I count up all the purple marbles. Oh wait, there aren't any. So that probability is 0 out of 29, or 0 as a decimal, or 0% as a percentage. Then our last one here, the probability that it is green or white. Again, there are 29 possible outcomes for me to choose from. green or white. So green, there are 8, and white, there are 6. So there are 14 total possible ways to pull a green or white. That's 14 over 29. Or as a decimal, 0.483. Or as a percentage, that would be 48.3%. Alright, so that was a quick review of how we calculate simple probabilities. We're always using the number of successful outcomes divided by the total number of possible outcomes in order to calculate the probability. And we can represent that answer in any of 3 ways: a fraction, a decimal, or a percent. And that really depends, our choice will depend later on context. Alright, that's it for this video. See you guys next time. Have a great rest of your day.